So, in the previous class that we discussed about theorems of exercise 10th chapter, circles, 9th class. Now here, we had discussed 10.1, 10.2, 10.3, 10.4, proofs of that, and we also discussed 10.5, in which the proof was not required, but the property was to be used. Now here today we are going to discuss theorem 10.6 and 10.7 of your textbook. NCERT book, that is, we are following the NCERT book. Page number 177, it reads as 10.6, equal chords of a circle are equidistant from the center. Now here they have also used the word congruent circle or of congruent circles. Congruent circles, you know, are of equal shape and size. Right? That is, the radius is equal. So here we are not going to draw two circles, we are going to talk about only one circle. He says equal chords of a circle are equidistant from the center. So this is a circle, correct? Center O. This is one chord, say A, B, and this is another chord, C and D. Both these chords are equal. What is given? Equal chords are equidistant from the circle. We are given that chord AB is equals to chord CD of a circle with center O. And what we have to prove, that they are equidistant from the center. Now distance, when we talk about distance, it is always perpendicular distance. So that means from this center of a circle, we will draw two perpendiculars on both these chords. O, this is M and this is N. We need to prove that OM is equals to ON and they are perpendicular distances. Right? This is what we have to prove in 10.6. But if we take a look at theorem 10.7, converse of that, it says chords equidistant from the center of a circle are equal. Here he is saying that the chords are at equal distances. So this is one circle, this is a circle, this is a chord AB, this is a chord CD, and their distances from the center is equal. Say this distance OM is equal to distance ON. Here distance is equal, here we have to prove, here chords are equal, then we have to prove. So what is given to us, we are given chord AB and CD at equal distance from center O, that is ON equals to ON. And what we have to prove? We have to prove that chord AB is equals to chord CD. This is what we have to prove. Both these theorems are respectively converse of each other. Here in this question we have to prove that these distances are equal. There it is given that the distance is equal. Here chords are equal. There we have to prove that the chords are equal. That is why on the previous class also we had discussed that two theorems at a time, 10.1, 10.2, if you have practiced it, if you have seen it in the class, 10.3 and 10.4 perpendicular one. Same theorem converse of each other. Construction, we will be doing certain constructions only. Let us join O to A and O to C or D. Anyway, alright. Construction, join OA and OD. Proof. Now, I have been stating this to you in class 9 again and again, that in 9th class geometry or rather any geometry, the most important part is observation. You have to observe whatever the things are given to you. So here also you need to observe what are the things given to us. Right? What is given to us? First thing given to us that these chords are equal. Second thing given to us that OM and ON are perpendiculars from the center. Right? And if these chords are equal, bisects the chord, that is theorem 10.3 of your textbook. We had proved it that if these chords are perpendiculars, are drawn to the chord perpendicular bisects the chord. So here we are going to write the same thing, because OM is perpendicular to AB and ON is perpendicular to CD. So therefore OM and ON bisects the chord AB and CD by theorem number 10.3 of your textbook. Perpendicular from the center bisects the chord. AM is equals to BM, DN is equals to CM. So therefore AM is equals to BM is equals to half of AB, and CM equals to DN is equals to half of CD. Now observe, sir, if the chords are equal, will their halves be also equal? Definitely, but AB is equals to CD. That is given to us in the question, that these chords are equal. So if chords are equal, therefore their halves are also equal. Half of AB equals to half of CD. That is AM equals to BM is equals to CM is equals to DN. Yes or no? We have used the theorem. The perpendicular from the center bisects the chord. That is what we proved in theorem number 10.3. I have written the statement number. You will write down the statement. Perpendicular from the center bisects the chord. Right. Now we come down to these two triangles. Triangle A and O and triangle D and O. In triangle A and O and triangle D and O. AM is equals to DN. AM equals to DN. Proved above. Yes or no? Okay. Angle M is equals to angle N. Angle M is equals to angle N is equals to 90. Given because OM is perpendicular to AB and ON is perpendicular to CD. Right? And lastly, is this side also equal? OA equals to OD. Both of them are radii of the circle. They are the radii of the same circle. So therefore, triangle AMO is congruent to triangle DMO by what congruency? Right angle. One angle is right angle. Opposite to right angle hypotenuse. Hypotenuse is equal, and one side is also equal. By what congruency? RHS. And if these two triangles are congruent, will the side OM be equals to ON? So therefore, OM is equals to ON. Reason C, P, C, T. Corresponding parts of congruent triangle. If the chords are equal, then the distances from their center is also equal. Clear? Now, here, when we come down to this question, here he is saying that this distances is equal. Prove that these chords are equal. So we will do the same thing. Same thing that we did over here construction. We will join O to A and O to D. Join OA and OD. Proof. In these two triangles again. In triangle A and O and triangle D and O. Is OM equals to BN? Given to us. OM equals to ON. Given to us in the question that it is equal. Then are the angles 90? So this angle is also 90. Angle M equals to angle N equals to 90. Write down the reason, because OM is perpendicular to AB and ON is perpendicular to CD. And lastly, is this side also equal? OA equals to OD. OA equals to OD, that is the radii of the circle. Therefore, triangle AMO is congruent to triangle DMO by what congruency? RHS. And if these two are congruent, this AM is equals to DM. AM is equals to DM. Reason CPCD. Now comes the twist over here. Here in the question you were saying that the complete side is equal, so their halves are also equal. But here is not saying that this AB is equal to CD. We have to prove it. We have to prove it. So here, now we can see that this is the perpendicular from the center. It does what? It bisects the chord. The perpendicular from the center bisects the chord. So will AM be equals to BM? Yes, sir. Similarly, DM will be equals to CM. Right? And after that, we will be proving that the complete side is equal. Now we know. What do we know? Perpendicular from the center bisects the chord. Which theorem I am talking about? That is theorem number 10.3. So therefore, OM and ON bisects chord AB and CD respectively. So therefore, AM is equals to BM is equals to half of AB, and DN is equals to CN is equals to half of CD. So this AM is equals to BM and this DN is equals to CN. Now check. Sir, if AM is equals to DM, AM is also equals to BM, so will this BM be also equals to DM? Yes, sir. Or else, sir, if halves are equal, AM and DM, their halves are equal, so will the wholes be also equal? Yes, because AM is equals to DM. Here we have proved AM is equals to DM. Proved above. So therefore, half of AB, that is AM. What is half of AB? AM. Half of AB is equals to half of CD. And if half and halves are equal, their doubles are also equal. Can you see? Can I cancel this half and half? So therefore, what is left? AB is equals to CD. So that means, if the chords are at equal distances, they are also equal. If equal chords are there, they are equidistant from the center. Very important theorems. 10.6 and 10.7. Now students, please practice these theorems in your notebooks. Write them. They are very important. And now we come down to the another important theorem, that is 10.8. Very important theorem again. 10.8. It says the angle subtended by an arc. Now this is the first time we are talking about the angle of an arc. So you have to understand what is the angle and what is the arc. And this theorem is very important. The proof of this theorem has been coming in examination several number of times. You need to understand the arc, you need to understand the angle. Theorem 10.8. What does he say? He says the angle subtended by the arc at the center. This is the circle with center O. In your textbook, page number 180, figure is given to you 10.28. I am drawing one of the figures. In this, the angle subtended by an arc at the center. Supposedly this is the arc AB. Can you see this arc AB? And this arc AB is making some angle at the center. End point is A, end point is B. Can you see this angle AOB? This angle at the center is talking about. Yes, this angle center is talking about. He says the angle subtended by an arc at the center. Can you see this angle? Is double. Double of what? Is double of the angle subtended by it. That is the same arc. At the remaining portion of the circle, if I draw an arc over here, draw an angle over here, then this angle will be double of that. So I am drawing it like this so that it is visible to you. Say, can you see this angle now? Can you see this angle? That is important. I am using the same names as it is given in your textbook. Say PQ and this is AB. Okay. I name it same A. This is P and this is Q. Clear? I am using it the same as your textbook so that you don't get confused. This is what the theorem is. What is given to us, we are given circle with center O and angle POQ at center and angle PAB on the circle subtended by the RPQ. Can you see this RPQ? What we have to prove? We have to prove that angle POQ is double of angle PAB. This angle is twice of this. In other words, if this angle is 60 degree, this is 120 degree. If this angle is 45 degree, this angle is 90 degree. If this angle is 90 degree, then this angle is 180 degree, that is a straight line. And this will also give us one important statement, that angle subtended in the semicircle is 90 degree, which will be applicable in class 10 also. So can you see this figure? You have to identify it very, very carefully. Okay? In your textbook, the proof is given to you, but we will be doing it some slight easier methods if you feel like. Somewhere the reasons are missing, so we'll write down the reasons also together here. What we want us to do, we'll observe that triangle first of all, that and those angles first of all. Angle POQ. Can you see this angle? That is at the center, O is the center, and angle PAQ, sorry, not B, PAQ. Again, it is PAQ. And it is on the circle. Clear? So one construction we are doing, we are going to divide these two angles not equally. We are going to draw a line from O. This is B. Clear? Join AO to be produced to B. B the complex of produced here. So can you see? I am numbering these angles now. Can you see this angle is divided into two parts? Maybe equal, may not be equal. We are not worried about it right now. Can you see angle POQ again divided into two parts? So I am naming these angles for our convenience, so that instead of writing PAQ, PAB, we write angle 1, 2, 3, 4. That will be easier for us. Alright? Okay. So I am naming this angle number 1, angle number 2. I am naming this angle number 3 and this angle number 4. Right? Proof. As I told you, in geometry, most important is your observation. What you observe. So let us come. Let us see. Let us observe. Whatever is visible to us, let us observe. We can see that there are two triangles. One is triangle POA and another is triangle QOA. Two triangles are visible to us, and if I observe it very, very carefully, I find that these two triangles are isosceles triangles in themselves. So why? OP is the radius, OA is the radius, and radius of the circle is equal. Isn't it? Yes or no? And similarly, OA is the radius, OQ is the radius. So again, these two triangles are what? They are having two sides equal. So that means they are isosceles triangles. Both of them are isosceles triangles. And if isosceles triangles are there, then the angles opposite to the equal sides are also equal. Theorem number 7.2 and 3 of your textbook. Isn't it? That is what we have to remember in 9th class. Theorems, theorems, theorems. So check over here. In triangle POA, POA. Can you see this triangle I am talking about? In triangle POA, OA is equals to OP. Write down the reason, radii of the circle. So therefore, angles opposite to equal sides of a triangle are equal. So therefore, angle number 3, will it be equals to this angle number 5? 3 will be equals to 5. Yes? Therefore, angle 3 is equals to angle 5. Equation number first. Similarly, in triangle QOA, similarly, in triangle QOA, OA is equals to OQ. OA is equals to OQ. Again, the radii of the circle. So therefore, angle number 4 is equals to angle number 6. Angle number 4 is equals to angle number 6. Angle 4 is equals to angle number 6. Reason, equation number second. Reason, same as above, angles opposite to equal sides of a triangle are equal. Right? Now, sir, we don't want angle 5 and 6, we want 3 and 4, and we want 1 and 2. Angle POQ is made of angle 1 and 2, angle PAQ is made of angle 3 and 4, so we want 3 and 4, 1 and 2. So observe again. For this triangle POA, is this angle 1 an exterior angle? Why AO was produced to B? The angle number 1, is it equals to angle 3 and 5? Exterior angle of a triangle property. The exterior angle of a triangle is equal to the sum of the two opposite interior angles. Again, it is given to you in your textbook. We have done this, we have applied it. Now, using exterior angle property of triangle. What is that? That is exterior angle of a triangle is equal to the sum of two opposite interior angles. So therefore, for triangle POA, angle number 1 is equals to angle number 3 plus angle number 5, equation number 3rd. Check. Angle number 1 is equals to 3 and 5. And for triangle QOA, angle number 2 is equals to 4 plus 6. Is equals to angle 4 plus angle 6. Equation number 4. Right? Now we want angle 1 and 2, the sum of angle 1 and 2. We are going to adding equation 1 and 2. So left hand side added to left hand side, angle 1 plus angle 2 is equals to angle 3 plus angle 5 plus angle 4 plus angle 6. Right? Now check from equation first and equation number second. From equation first and second, angle number 1 plus angle number 2 is equals to angle 3 plus angle 5. Check this angle 5. We don't want angle 5, but 5 is equals to what? 3. In place of 5 we can write angle 3. We don't want angle 6, but in place of angle 6 we can write angle 4. In place of angle 6 we can write angle 4. Angle 4 plus angle 4. Angle 3 plus angle twice of angle 3. Angle 4 plus angle 4, twice of angle 4. 2 is common, so you are left with angle 3 plus angle 4, and here you are left with angle 1 plus angle 2. Now from figure, check. From figure, angle 1 plus 2. 1 plus 2 is which one? POQ. So therefore, angle POQ is twice of angle 3 plus 4. Angle 3 plus 4 is angle PAQ. PAQ. Hence, true. That means the angle subtended by the arc at the center is double the angle subtended by the same arc at the remaining portion of the center, remaining portion of the circle. Students, very important theorem. 10.8. Now the application of this theorem, sir, where do we apply this theorem? Where do we get it? How do we, where do we use it? You can just see. I now showed you that this angle at the center is double. Now how do we conclude from here? How do we apply it from here? Just check. One very important statement arises from this. Very important statement. It is not given to your textbook as a proof, but it is given to you. What does it say? Just check. Supposingly this is a circle, right? This is the center. This is the center, and I draw this line A, or I name it as P and Q itself so that you don't get confused. P and Q, and this is O. What is this line? This line is a diameter. This line is a chord. Why is it a chord? So it is joining 2 points on the circle. And why it is a diameter? Because it is passing through the center. So it becomes what? A diameter. It is a straight line. It is a line segment joining 2 points on the circle passing through the center. That is the diameter. Now, if it is a straight line, how much is this angle? Sir, 180 degree. All of us know that if it is a straight line, the angle over that line is how much? 180 degree. Now, if I draw another angle on the same arc, this A, is it on the same arc? So what we have proved, that angle POQ is twice of angle PAQ. This angle is double of this angle. This diameter is dividing this circle into 2 parts. This is a semicircle, this is a semicircle. So can you see, angle in this semicircle is half of this. How much is POQ? Sir, 180 degree is twice of angle PAQ. 2 is in multiplication, goes into division. So 180 by 2 is equals to angle PAQ. So 180 by 2 is how much? 90 is equals to angle PAQ. This angle is 90 degree. That is angle in a semicircle. Can you see? This is a semicircle. All the angles in the semicircle will become how much? 90. Yes, but point A has to be on the circle. And this statement is verified in the form page number 181, just above theorem 10.10. Just above 10.10 it says that angle in a semicircle is 90 degree. Right? And from the very same theorem, we can 10.8, we can also prove the theorem number 10.9. Theorem number 10.9, it says that angles in the same segment of a circle are equal. Please check. Say this is the circle with center O. This is a line P and Q, P and Q. This is the arc PQ. This is the angle. Right? And this is what we have proved right now. A. Angle POQ is twice of angle PAQ. We have proved right now. Right now. Right? So, if this angle is x, how much is this angle? Sir, 2x. Isn't it? Now observe carefully. If I draw another angle like this, say B, so angle PBQ, will it POQ, it will be twice of angle PBQ. So if this is 2x, how much is this? X. So are these two angles equal? Why? They are in the same segment. Any angle I draw, they are in the same segment. All these angles are going to be equal. Why? They are in the same segment. Angles in the same segment of a circle are equal. Clear, students? So these are very, very important theorems. Theorem 10.8, 10.9, 10.10 we shall be discussing, but the proof of 10.8 is very, very important. Few more theorems are there whose proof is not required, but we shall be discussing those theorems, right? That is cyclic quadrilateral, because they will again be used in class 10. Their properties will be used in class 10. Alright, so in the next video, next class, we shall be discussing about that.